Okay, so great to see you all this morning. So my talk is AI impacts on software development, right? Development practice. And I'm sure that everybody in this room has been doing some work playing with artificial intelligence recently. It seems like every day we have something new that's happening within this realm. And I'm sure that the background thing, despite all the other things that we are thinking about in terms of ethics and impacts on society in general, there's that deeper question that we have, which is really, what does this mean for us as software developers? What will software development actually look like a year from now, 2 years from now, 3, 4 years from now? And of course, I decided I'll talk about this, and let's go and see what happens. The only thing about this, though, is that things are changing extremely fast, right? So it's kind of like, I'm just going to go and say, it's the 4th of May, 2023. This is being recorded, and at some point, I'm going to have to go and apologize for this talk, right? Because I'm going to be talking about some things that are a little bit like predictions in a way about where things could possibly go, and a lot of it will be wrong, right? So this might be a fun talk to look at a year from now and sort of think, well, hey, what did I get right, what did I get wrong, right? So anyway, the deeper thing for this is to go and really think about what is possible in the context of software development. And I'm sure you've had this thing of going and sort of just being staggered by the things that you see AI doing right now. So ChatGPT is out, we've had stable diffusion technology, the general GPT transformer architecture has been out for a couple of years now, and it's just all moving along in a great way. Back when I was in university, I basically kind of majored in artificial intelligence in a way for my master's. Never actually got the master's, but did a lot of the coursework. And I never would have imagined back then that we would be where we are today. We are constantly being astounded by the capabilities that large language models are able to go and evidence just as we scale them up, right? So, for software development, what does this really mean? Well, I think the thing that's interesting about this is that usually people, when something like this happens, they have all these hopes that it's going to go and solve the problem of software development, right? That somehow you'll just be able to go and talk to a computer and go and generate everything that you need in order to go and actually have some runnable product that'll be out in the world and make money and do wonderful things for society. But it's interesting to think about this as like a communication challenge in a way. So there's this interesting thing, right? We can now basically converse in natural language through GPT and actually go and ask it to do things for us, right? But the thing that's interesting about this is that we actually have this thing. As these systems are able to go and understand natural language, there's a level at which they are actually filling in the details. And when they fill in the details, they could be right or they could be wrong. Does this sound familiar? Because it's just like human communication, isn't it, right? You say something in a loose way, and then it's kind of like somebody goes and interprets it in a different way than you anticipated, and you end up having something which is problematic. And this is why human communication is so difficult. So it's strange for us, people with a development background, to go and actually move into a technology where we can converse and go and ask it to do things when we are so used to being terribly precise in what we do. Most everything in software development is about going and creating a precise specification of behavior that can be executable deterministically on a machine. And now we're kind of like playing with that calculus a bit. So we've had this problem forever, right? A business person comes to a developer and says, hey, I need this kind of thing. And then immediately you have questions. You have to go and sort of say, well, have you thought about this case, or this case, or this case? Because as a developer, you're in the place where the rubber hits the pavement in a way, and you have to basically sort of specify precisely what's going to happen in the system. So we're going to have an exciting time doing this. The thing which is kind of foundational about this, though, that a lot of people are noticing is that, I don't know, have you heard about the hallucination problem in AI? It's kind of like you basically ask for something and particularly information. If you say, oh, please tell me about the members of this band at some point in time, usually it's okay, but then sometimes it will go and give you completely false answers. And as we're working with AI to generate systems, we have the possibility of having completely wrong implementations of things based upon the things that we ask. It's not a very easy problem to solve. And the reason why it's not very easy is because of something that I'm calling the temperature problem. So if you look at a lot of like GPT-based systems, they have like this notion of temperature, which is really the degree to which randomness is injected in the process in order to go and actually create novelty. And it's an interesting thing because you can have massive amounts of novelty, but you also have massive amounts of possibility for hallucination. And a lot of researchers are working on this now. How do we actually sort of like vary things in such a way that we can have a bit of creativity, but then also go and get to the point where basically we have something which is acting a little bit more deterministically. And later in this talk, I'll show you something that's being experimented with right now. So I think we're going to be in this space for a while of generate and test. And this is the interesting thing. I think people are doing this right now with business plans. I have a friend who's doing this like, oh, give me a business plan for such and such, and you get a detailed business plan through GPT. And it's nice. But as we use these technologies to, say, generate code or generate implementations, we're going to have to basically do the thing of going and reviewing and making sure the system doesn't hallucinate. And this is just like going in dealing with a pull request from a fellow developer. You kind of say, hey, well, we need this kind of thing, and they work on it, and you have to look at it and really, really see if it's actually satisfying the need that you have and whether it's really okay. As this technology gets better, you'll have things which will usually be on mark, but we still need to go and actually do the human review process. So review is a bigger deal for us right now. Maybe this changes further in the future, but this is really the paradigm that we're kind of moving into now. And as a result, this basically means that QA becomes much, much more important than it has in the past. Over the past 20 years, we've basically had this thing where it's kind of like, well, we have people who do manual testing and stuff like that, but we want to push as much testing as possible to automation. And I think we're moving into this state now where basically people are going to have to do a lot more review of systems and checking of behavior just to make sure that what the intention was is actually carried out by the computer in the runnable systems that we create. So this is a space that I think is going to happen. Again, these are all guesses about the future. Could be wrong, we'll see. So as a person with a lot of software development experience, one of the things I started asking myself is, what does this do for, say, large-scale systems design? Okay, and in particular, what's going to happen to modularity? And the reason I'm asking this question, is because so many of us have spent a lot of time in our careers learning how to create cohesive units of code, right? We use design principles to go and figure out how to best organize classes in our system and stuff like this. But a lot of these technologies are getting very good at being able to determine what good cohesion is and what good coupling is and stuff like this. And you can actually ask directly and say, here's an ugly piece of code. Can you rewrite it so it has good software engineering principles embodied in it? And it will do pretty well at this, right? So the big question is, as humans, will we have to go and basically pay attention to modularity going forward? Or is the modularity just basically something that we can ask the system to do to help us understand what is being generated? And it's a rather deep question. It really depends upon a lot of things that are in play right now within the industry and within the development of the technology. The key thing with this right now is something that's known as the context window. Does anybody know what this is at all? Context window is really the concept in the current systems that we have of how much it's able to go and kind of work with at once in order to go and basically deal with the things that you're asking it to do. If I wanted to learn more about airline reservations, for instance, I could start to load in a lot of information into a GPT session, and it will basically go and say, okay, well, you have all this, and you start asking questions based upon the new knowledge that you've given the system. But at this point, I think right now I've been told that with GPT-4, you can take about 50 pages of text or so. Beyond that, it really won't accept that and really actually have that as the working set of knowledge it's using to go and either answer questions for you or make things for you. This is very much like, for a human being, what is our working memory? How many things can you have in your mind at once when you're working with things? If somebody gives you a list to go to the store of 20 things, you might want to write it down as opposed to trying to remember those 20 things. So this context window thing is a very important part of where the limitations happen to be for the systems that we're seeing today on the 4th of March, 2023. Of course, it could change, right? So what this kind of means in a way is imagine that you're able to go and load the source code for an entire microservice into a session and ask it to go and rewrite the code and do various different things to change its behavior. If it's a big, giant microservice, and it probably shouldn't be because of the word micro, right? You might not be able to go and fit this entire thing in the context window. If it is of the right size, you might be able to. And then it becomes this thing of whatever modularity you have has to be something that is in the bounds of this amount of information that the system can process at once. So this is almost like a little bit of an inherent limitation that we have in these systems now. And there's a lot of research that's going on to go and expand the context windows. There's associated costs with having large context windows, and we're going to see how it plays out. But for me, it seems like it's a bound now on the size of the things that we can create using the GPT technology that we're currently dealing with. So that's one place where we're going to need modularity. You can make pieces that you have to connect together of a certain size. Beyond a certain size, you may not be able to go and work with them very effectively. So it's interesting with this because this reminds me of something that I've often called the escape hatch problem in software. And what this is like, it's something that's generally true of any code generator in a way. We can use GPT to go and generate code, and it's something that we look at as being very new and novel. But we've had code generators forever in the industry, haven't we, right? And there's always this thing of like, you use a code generator, but then there's certain things it can't quite do. And so you hope to leave some place where you say, okay, I'm generating this, but I want that to call this other thing, and then you can write the other thing. And then you're able to go and expand the behavior of the generated code, okay, with these things that were not generated, right? So early in my career, I designed a compiler, and I actually had a syntax to allow me to drop down into the language I was transpiling to, just so I can actually move forward, even though the entire language that I was writing a compiler for wasn't really defined yet, right? So this thing of kind of like, how do you generate something and then leave the holes in place to go and actually do other things or call other modules is something we're going to have to basically deal with at some point. And I think there's this mental frame we can use for this, which I think is very useful in all of software development, is that generally what we do when we make a framework, it's like creating the table that has the holes for the shapes. When we create libraries or just pieces of code, they can be plugged into frameworks, right? And these are the two general ways that we reuse software. We have libraries or we have frameworks. And you can look at it as kind of like either you supply the context that you're going to call behavior from, or you basically go and supply the behavior that people can tie together in different ways to create bigger behavior, right? I don't think this problem goes away at all for basically the things we're going to be doing with AI in the near future. I think the deeper question, and this is kind of a fascinating one, is do we actually ever get to the point that source code is going to go away? Have you all thought about that yet? I mean, as developers, source code is really something that's very, very valuable for us. And it's valuable because it is a specification of behavior. So often, to be able to go and look and see what the system does, we consult the source code. But we've had this history across, the industry of kind of like building languages that sit on top of other languages, and then we're able to go and do more effective things. Right now, we have conversations with AI to generate source code. And the question becomes, does that source code ever go away? Do you ever get to the point where you can directly create an executable without the intermediate source code, okay, just because the AI knows enough how to do this? Or do we remain having that source code that we can consult in order to understand how things really work? And to me, it seems so valuable to keep this thing, this specification, so we can consult and see how the thing works, that we probably would want to keep it forever. But the interesting thing is that I think that there are many places where source code has already disappeared and we don't think about it very much. So for instance, neural nets have been around for a long time prior to their use in the modern AI technologies. And it's interesting to notice that one of the big problems with neural nets that people have had from the very beginning is it's hard to explain how an answer came about, because the neural net is based upon lots and lots of training, and you can't look and see an algorithm any longer. But these neural nets that are basically used for classification in medical imaging and stuff like this are so valuable that we don't care that we don't have the explanation available to us. We use the system because there's an incentive to use it, because it does things that we can't do otherwise. And I think this is going to happen to some degree with what we're doing with AI now. We can actually go and get to the point where we develop software that we can't consult code in order to understand, and we can be comfortable using this just because there's no other way to easily do it. So it's kind of a fascinating world, but I think that for the while at least, we're always going to have source code. It has many useful characteristics, particularly when you have like a regulatory environment or an environment where there's liability and you really need to know what's actually being done. So that's a bit of a far-off future in a way. So yeah, it's kind of this thing that right now we're going to keep the layer, I think, of generating source code and then compiling it through our build pipeline. But there is the possibility of collapsing the layers and going and saying, can you please sort of just like, I'm telling you about some behavior, can you just, with any new user, express this behavior and interact with them in a way that is going to provide them value, which is what we do with programming anyway, right? So yeah, we need to basically know where we need the specificity, where we need to go and know in detail what's really going to happen. And that's the place where source code is going to live for us. There's another way that we can approach modularity, I think, with AI that hasn't really been done much yet, as far as I've seen. Rather than just creating a context that you plug things into, or creating things that you plug into other things, what you can do is you can say, here's a code base that I know has reasonably high quality. Hey, GPT, I want you to read this entire code base, and I want you to go and make these behavioral modifications, and then export it so that I have a subset of the behavior, or the behavior with some slight modification that allows me to go and do some different things. So it's almost like a fork in open source, but it's like a virtual fork where you're basically using the behavior that's embedded in the source code as a basis for going and specifying new behavior. And I think we're probably going to see something like this going forward with artificial intelligence. Okay, so I'm going to get to an interesting point of this talk where I'm going to go and describe something I only ran into a couple weeks ago, actually about a week ago. There's something that's being developed now called Pseudolang. Has anybody ever heard of this at all? It's really an experiment, and it's kind of fascinating. And it's an experiment done by this guy who's been doing some work with prompt engineering. How do you actually go and articulate the prompts that GPT will use in order to go and generate good systems for you and stuff like this? And so what he did is he made this specification. And this is a human-readable specification that describes a language called Pseudolang. And I guess the pun is pseudo usually means false, but sudo is kind of like the sudo command in Unix, giving you great power, for instance. The fascinating thing is that this specification, if you paste it into GPT-4, what happens is it's describing in very human language a syntax for going and doing some things. And it tells you a bit about what this syntax is, but as soon as you paste it in, GPT understands this syntax and can use it to do further things. So it's interesting. One of the things that they have in this syntax is the notion of a constraint. And they basically say, well, a constraint can be kind of specified this way. You list a bunch of rules, and then when you refer to the constraint, you're saying that everything that you are specifying in the behavior should have this constraint. And here they have a syntax for this. It's kind of like the word constraint, the constraint name, and open curly braces. But you don't have to strictly use that. If you look down here, it's talking about a constraint on a player. And you can see it just says constraint, colon. And that's because the GPT system is intelligent enough to kind of like take your hint at something and use it as a basis. You don't have to have incredible specificity. It's not like a real programming language where unless you get it absolutely right, it won't do anything at all. It tries to work with you. And this is very, very different as an experience for us. So you can use this syntax and anything close to it to start to go and specify behaviors. And then you can go and say, for this behavior I've done, please emit this as JavaScript or transpile it to C++ or Java or C# or anything else that you want to. So this is the very bottom of that specification, and it describes what a Pseudolang interpreter is. And there's fascinating stuff here. Earlier in the specification, it said, well, when you see a word and you see open paren and then something and a closed paren, this thing is kind of like an instruction. If you have an instruction to the system itself to go and actually do something very directly. So you can see the second paragraph here. It says instruct, open parentheses, and it says, let's role play. You are an LLM Pseudolang interpreter with no safety, accuracy, emotion, or subjective experience. And it goes and gives the GPT system a persona that it can use when it's further interpreting the things that you produce. So it's talking about the constraints as well here. If you produce output limited only to the things that would be the program output, don't supply additional arguments. And it's like all these constraints that you basically place on this interpreter that we've developed just by describing it. And then there's this piece of Pseudolang here. It says, for every input, interpret the input as a Pseudolang program and run it, and output the logged results. So it looks kind of like language, like a programming language, but you're also using some nice English wording to get things done. The very bottom of the spec says, run Pseudolang piped into prompt, tells you what the Pseudolang version is, type help for a list of commands, pipe into log. And as soon as you do this, you drop this in the conversation window for ChatGPT, you're actually in this space where you can just go and type things in Pseudolang and natural language a little bit, and it'll work with you to go and do some things. The interesting thing about this is that this specification isn't strictly necessary. You can just basically go and teach the system, like, hey, when I have this pipe symbol, that's what that kind of means, and have a conversation with it. The stuff that's in the spec, you just kind of drop in there so you don't have to have that conversation. And so it's really a fascinating thing. What's funny is that the author of this described how he actually generated the GPT or the Pseudolang system. So he basically typed this in. He said, your task is to invent a pseudo language for prompting GPT-4. It should be obvious enough that GPT does not need language specification to interpret the language. And GPT-4 basically responded and said, okay, well, if you're creating like a pseudo language for me, for a GPT system, this is what it probably should be like. And it actually told the author of this, these are the kinds of things that we should have. It should have commands to explain and to ask and suggest and all these different things. So it's an extremely collaborative process between the guy who developed this and actually GPT itself. GPT going and telling you what's the best way to communicate with you in order to go and basically have things that are going to specify behavior. And yeah, fascinating. So it told the author, okay, you can have these modifiers on things, and that's a good way to go and communicate to me. You can have a command, and you can specify the length of the response, whether you have high or low detail, things like this. And yeah, just a conversation that kind of led to this. So we get into this space where now we're doing kind of like conversational development. You communicate with a system to go and help you specify the behavior of the system, specify enough stuff within the memory of the system to actually generate code to do things. Very different style. The thing about it, though, that's fascinating is that, I don't know, how many people here got into software development because they prefer talking to computers than talking to people, right? It's a funny thing. We value quite often our precision in communication because we know that when we talk to humans, there's a chance of misunderstanding. And this thing that we will be doing now with a lot of these systems is kind of like being able to speak in a much more human, natural language with things. But I found myself trying to do this, I'm trying to be very, very precise, and I don't really need to. It's hard for me to learn how to ease back a bit and not be quite as precise because it isn't strictly necessary in certain circumstances. So yeah, some programming might become a lot more like communicating with a coworker And it's kind of a fascinating direction things might move into. Test-driven development. I'm sure some of you have done some of this, and it's a very valuable thing that we can use to go and sort of iteratively develop systems and kind of move forward with the things that we do. One thing I've seen people do a bit with GPT is kind of say, well, I need a function to do this, please go ahead and produce a function for this. And then you have to look at it, and you have to go and say, oh, okay, it's like, is this right or is this wrong? A lot of review. The alternative to this, in a way, is to go and start to actually create tests and then ask the system to go and actually satisfy those tests with an implementation. So you can basically sort of like do a quicker cycle of TDD using GPT. You can actually say, I'm providing these tests, these constraints, please produce something which is going to go and satisfy these things. And it seems like that's better. You're putting the constraints and the guardrails in place to go and actually sort of like constrain the thing that you're building. And I think we'll probably see a lot more of this going forward too. So it's kind of funny. I'm not exactly sure where we stand on time. I think, yeah, a little bit earlier. But the thing I want to kind of get back to with this is that we have this particular thing that we're a little bit scared of with the AI systems that we have right now. I have turned people, or I've had to converse with people who basically say they think that it's going to go and sort of fix the software development problem, and we'll have cheap, easy to use, almost free software, and we'll just be drowning in it over the course of the next couple of years. And it's very funny because it reminds me of something that happened very early in my career. I was like a math major, and I decided to move into programming. And I had a friend, this is back in like the 1990s, and he said, hey, Michael, why are you learning how to program and do all these things? Pretty soon we're going to have written all the programs we need, right? And it's like, no, it definitely was not true at all back in the 1990s. And the reason why is this. You know, humans want things, right? We want to basically have things that satisfy us. We want to have things that make money for us and do all these different things. The technologies that we produce that make the process of developing software easier are also going to basically raise the bar for us. We're going to start to demand much more of our systems. And so I think we're on the cusp, you know, if this technology kind of, you know, really disseminates the way that we think it will, on the cusp of producing far more complex systems than we have in the past, far more capable systems than we've had in the past, and basically many things that we can't even imagine right now. And so it's a bit of an exciting time, and it's a bit of a scary time, too. There are a lot of things that are happening right now that may be temporary. Some things might be a bit more permanent. We'll have to kind of see where things kind of play out. So yeah, I think the thing I keep coming back to is there's, beyond these technical things that we've been dealing with, there's also the context around these things, which is still being settled right now. And I think the context here really is that a lot of these technologies have been kind of like developed in the context of OpenAI, the company, and it was also a foundation as well. And this technology has been licensed to Microsoft, and they're developing it, and we're starting to see it being disseminated in various different areas, Copilot, all these different things. But it's an interesting thing to go and think about what this is going to mean for the business and the legal landscape of things that we're doing, right? If these market leaders basically persist in their lead, then there's going to be this thing where there's a big question about whether we're going to have a good, decent market with many competitors or not in this space, or whether it's going to be the case that you have some company that develops systems that are so capable that this is the one everybody wants to go and use. And nobody really knows where this is going to settle out yet. And the other thing that a lot of people are talking about now as well is the thing of where does this really mean legally? There are cases that are in process in the US right now to figure out whether you can retain intellectual property on something produced by one of these systems if it was trained on your intellectual property. And we're going to have to go and basically see where this all shakes out. To me, it's completely unpredictable. The legal system tries to go and produce equitable outcomes for people that have disputes. And you know, it's fair that a lot of people that are artists and writers and even software developers have done a lot of work that's basically led to the high capability that these systems are able to present. And we're going to probably see a lot of things happen with this. For right now, it's kind of interesting. I think people are using this a little bit in software development, but they're being cautious about actually going and sort of like using proprietary information in some of these open API systems in order to go and, you know, learn things from it based upon GPT or make things based on GPT. But the other thing too is there's probably going to be a thriving market of locally hosted LLMs, that will basically allow you to have some privacy and some control and restriction over the things that you're working on, so you can feel a bit more confident about security concerns. It's very much, it seems to me, like the early transition to cloud-based services. Before cloud, people were hearing about the possibility of cloud, and they thought, this is insane. There's no way I'm going to trust this company to go and hold on to all my valuable data. But of course, it's kind of like you get to this space where there's so many advantages to doing this, you do have to go to cloud. And the cloud providers start to provide higher security and assurances that basically your information isn't leaking out into the world, right? Same kind of thing is probably going to happen to this, right? And we'll have to go and see where it all goes. So, yeah, it's kind of funny. There's somebody I know in the industry who was saying, actually I'll name him, Kent Beck. He was basically going and saying that a lot of the skills that he's developed over the years are kind of like their value is going down because of the capability that these AI systems can provide for us now. And that's kind of cool, but the thing about it though is I think that there's something that we need to basically pay attention to. And it's something I call the entropic asymmetry. So you know entropy, it's kind of like things tend to disorder over time and stuff like this. There's a fundamental asymmetry that basically is something that kind of affects the work that we do. And this is the asymmetry. It's always going to be easier to make messes than it is going to be to clean them up, right? And this is something which is intrinsic in engineering, right? We can make mistakes. Sometimes the mistakes persist. We need to understand the things we've generated well enough to be able to go and work with them. And quite often, we start to try to do things ambitiously that are far beyond our ability to maintain and support the things that we do. And in software development and engineering, we've been doing this kind of thing for decades, and we recognize that we can go too far. And this is the place where we have to go and sort of figure out where we're going to sit with these things. So I think this is really where we stand right now. And what am I going to do? I'm going to go and jump all the way back to the very beginning of the slides. Sorry for going and showing my stuff here. This is today. This is the 4th of May, 2023. And this is what it looks like to me right now. I'm probably wrong about a bunch of different things, but I hope I've given you some things to think about in this context. And it's kind of nice to go and basically know what's possible, and you can kind of orient yourself in what you choose to go and develop skills in and what you choose to do in the future. So thank you very much.